We're surrounded by all these different elements, right? But it turns out that more than half of the ones heavier than iron have this incredibly mysterious and violent origin story. So today, we're going to crack one of the biggest cases in all of astrophysics, the cosmic origin of gold. No, really, think about it for a second. That ring on your finger, or the platinum in your car's catalytic converter, even the uranium that powers a nuclear reactor, where was it all born? It's a question that takes us to the absolute most extreme environments you can possibly imagine in the entire universe. Now you might be thinking, oh, that's easy, it comes from stars. But here's the twist. Stars are amazing at fusing lighter elements together, but that whole process slams into a brick wall at iron. See, making anything heavier than iron by fusion actually costs energy instead of releasing it. So our main suspects, the stars, they have a rock-solid alibi. The universe needed a completely different, way more violent method to forge these heavy elements. And that, right there, sets the stage for a kind of cosmic detective story. We're talking about a 60-year-long investigation into a celestial gold heist. And like any good mystery, the key to solving it is to first understand the criminal's MO. That method is called the R process, and that R stands for rapid neutron capture. Just try to picture this. You have an atomic nucleus, and it's getting absolutely pummeled by a frantic, unbelievable storm of neutrons. It's forced to absorb them so fast it literally doesn't have time to decay and fall apart, which builds it up into something much, much heavier. This slide really lays it out perfectly, the difference between the R process and its much calmer cousin, the S process. So over on the left, you've got the S process. It's slow, it's methodical, it happens pretty neatly inside aging stars. But on the right, that's the R process. It's just pure chaos, a frantic flood of neutrons that only happens in the most violent places we know of, creating these bizarre, unstable atoms that might only exist for fractions of a second. So the big question is, where in the entire universe can you possibly find an environment that's extreme enough to cook up one of these unbelievable neutron storms? Well, the conditions are just staggering. I mean, you need a neutron density of over a quadrillion neutrons per cubic centimeter. To put that in perspective, that's like cramming almost a full gram of pure neutron matter into the size of a sugar cube. Then, combine that with temperatures in the billions of degrees Kelvin, and this whole thing has to happen in a flash. There are very, very few places in the universe that can even come close to fitting that description. And for decades, this was the central mystery. Physicists knew the R process had to be happening somewhere, but they just couldn't find a crime scene that actually matched the evidence they had. The theory itself was laid out way back in 1957, and for a long, long time, everyone thought exploding stars, supernovae, were the obvious culprit. But the computer models, they just never quite worked. They could never really produce an environment that was neutron-rich enough. It took a full 60 years for our technology to finally catch up with a theory and actually find the forge. And that breakthrough, oh man, it was one of the most incredible astronomical events anyone has ever witnessed. So, on August 17, 2017, scientists didn't just see something, they felt it. The LIGO and Virgo observatories detected ripples in the very fabric of space-time itself. And those ripples were coming from two neutron stars, these collapsed, city-sized cores of dead stars spiraling into each other and then colliding in a spectacular crash. And this is absolutely the crucial point. For the very first time, we didn't just hear the collision with gravitational waves, we also got to see the fiery aftermath with telescopes across the entire spectrum of light. This single event kicked off a whole new era of astronomy, where we can observe the universe with multiple senses all at once. It was a total game changer. So what did we see in the wreckage of that incredible collision? An unbelievable amount of heavy elements being created right before our eyes. The estimates suggest that this one single event forged somewhere between 3 and 13 Earth masses of pure gold. Let that sink in. 13 Earths made of gold. This was the smoking gun everyone was looking for. By analyzing the light from the explosion, which we call a kilonova, scientists found the unmistakable signature of strontium. Now, why strontium? Because it's one of the lighter of the heavy elements, and seeing it is a key fingerprint that tells you the R process is happening. It was direct, undeniable proof. We were watching heavy elements being forged in real time. So case closed, right? Neutron star mergers make all the gold. It all makes sense. Well, like any good detective story, there's always one last twist. It turns out there's a kind of time delay problem. See, these mergers can take a really long time to happen, sometimes billions of years. But we see heavy elements in some of the universe's most ancient stars, stars that formed way before the first neutron star pairs would have had time to merge. So one type of culprit can't explain all the evidence we see. So the investigation has expanded. What was once a single suspect case is now a full-blown cosmic most wanted list. We've still got neutron star mergers, for sure. But now we're also looking at collapsars, which are these hyperviolent types of supernovas, and there's even a brand new suspect that just recently joined the list. And this just shows you how fast this field of science is moving. Just last year, in 2025, scientists confirmed that giant flares erupting from magnetars, these are neutron stars with magnetic fields that are just insanely powerful, can also create the right conditions for the R process. They don't make as much gold as a big merger, but they happen a lot more often, and most importantly, much faster. And that helps solve that time delay problem for those ancient stars. So why does all of this cosmic detective work matter? Because the legacy of these ancient, incredibly violent neutron storms is literally all around us. It's in our technology, it's buried deep in the Earth, and it's even inside our own bodies. Think about this.
The very iodine your thyroid gland needs to function was forged in a cataclysm hundreds of millions of light years away, billions of years ago.
It really changes how you look at the world, doesn't it? Every single heavy atom has this epic story of fire and fury, of a cosmic collision or a stellar explosion. We are, quite literally, made of the debris of colliding stars. It really makes you wonder what other incredible cosmic stories are just waiting to be told in the very next thing you touch.